camera so I can show you around, and I'll keep talking, and hopefully someone's taking notes of questions, and then we can do a Q&A a little bit later. So like I said, we're in the change room. So we've got to put on shoe covers, some kind of cap, face covers, and we have smocks we typically will put on, safety glasses, and you know, we have little cubbies to keep our stuff. And then we're real big on safety, so we have lots of safety stuff. We got a help, I can't get up button. We got a bunch of these all over the place, so if something happens, you know, our customers and our users can push the button and get help. Defibrillator. We also have different kinds of waste, right? So this is for flammable rags. That's for general trash. And then we got fire extinguishers and fire alarms and all of that stuff. So we like to keep things very safe here, and you know, and we operate under very safe conditions. All right, so a little bit about this place. This is the Manufacturing Training Technology Center, which is part of UNM. We're on South Campus, which is just south of main campus. And we have about a 10,000 square foot clean room here. And the clean room is used to make little itty bitty things. So small stuff. We can print things down to about a micron or so in here. And we can run 4- and 6-inch wafers. Wafers are silicon wafers. They're made out of silicon and crystalline silicon. And we can do different processes here. And I'll go through the different bays and chase areas to explain that to you. So what makes a clean room clean? Well, we have what are called Hepa filters. Okay, Hepa stands for high efficiency particulate air, or high efficiency particle attenuator, depending on who you talk to. These were invented by Los Alamos National Labs during the Manhattan Project because they wanted to filter out the fine radioactive dust that they made when they were making the parts to make an atomic bomb. And then later on at Sandia National Labs, they took the Hepa filters not just for filtration, but they put them on the ceiling to create a clean environment for assembling electronics. And that's called a clean room. So Los Alamos, home of the Hepa filter. Sandia National Labs, home of the clean room. So New Mexico's pretty advanced in terms of high technology stuff. And of course, clean rooms are used now to make pharmaceuticals, to make small widgets, computer chips. So we have a whole bunch of companies in Albuquerque that have clean rooms, pharmaceutical companies, nano ink companies, and also the big ones like Intel, MCore, and smaller companies like HT Micro and 3D Glass Solutions. So there's lots of jobs for people who know something about clean rooms and how to operate in a clean room. Okay. I just lost you guys. Hang on a second. I think I'm back. Let me flip around. Hopefully you can still hear me. All right, so we're going to go down this aisle here. We've got lots of silicon wafers here. These are 6-inch wafers. There's some 4-inch wafers here. They're a little bit smaller. Let me show you what a finished product looks like. This is something we do in our classes. We make pressure sensors, and you can actually see through it. All right, we got holes in it. And the little yellow windows, that's where the membrane is still in place. And if you look closely, ooh, this camera's pretty good. You can see a circuit. Okay, you can see how big they are because there's my thumb. Okay, these are Wheatstone bridge circuits. So we put the circuit on top of a membrane. The membrane bends, the circuit changes its electrical properties, and we have a resulting pressure sensor. So I teach a couple of classes, and one of the things we teach about is how to make a pressure sensor. So this fab is used for teaching, research, and also for companies to use. And like I said, we've got nobody in here today because our general exhaust isn't up yet because we had to replace the motor. All right, let me go into the first aisle here. Hopefully there's no one in here. Okay. This is a photolithography bay. I'm going to talk a little louder since you can hear the fan noise. Our Hepa filters are still running. And we have a lot of different equipment. So this here is a supercritical dryer. One of the systems we use to dry things without using liquid. If that makes any sense. This is a solvent bench. Okay, so solvent benches are used for solvents. Solvents are flammable, so that's why it's made out of stainless steel. In case there's a fire, we do have a carbon dioxide system that douses everything inside with carbon dioxide gas, which makes it so things can't burn. Here's an acid or caustic bench. Right, these are acids and bases. Typically, these are made out of some sort of plastic material that's inert to acids and bases. So a lot of times you can look at the solvent and acid benches to see, what you can use in it. Ultrasonic cleaner. Here's some more caustic bench. Another caustic bench. We can use buffered oxide etch, which actually dissolves silicon dioxide or glass, so we can etch glass in this thing. This is our coat system. So we can put thin layers of photosensitive material so we can transfer patterns onto the wafer. And again, a wafer is silicon crystal, and that's what we build computer chips on top of, and also micro devices. This is what we call a contact printer. So we use a contact printer to align patterns to previous patterns, and we can use it to transfer our design onto the wafer itself. So typically we have masks. These are the patterns that we're going to transfer. Let me make sure I'm showing you this. I'm having a hard time opening it with one hand. I'm going to go ahead and put you down for a second. I'm still here. There we go. Now that's what a mask looks like. And it's basically a repeating pattern, and you have a pattern for each layer you're going to make. Okay, so those patterns are transferred to what's underneath step by step until you build your device. So we put photoresist onto a wafer, we take it over again to the contact printer, we transfer the pattern to it. So when the light hits, the photoresist changes its chemistry compound or its chemistry makeup. And then we go through a develop process, and that's like developing film. So we remove the areas of the photoresist that were exposed to light, and the parts that weren't exposed to light remain on the wafer itself. And then that resist is resistant to etch. So then we can go ahead and etch the material that's exposed and protect the material that it's over. All right, so this is what we call the photolithography bay. So that's where we transfer the patterns onto the wafer. Okay, and then we have another bay. Okay, well, let me show you a chase. So bay is where we make the stuff. Chase is where the equipment sits, a lot of the equipment. So you don't want to spend a lot of real estate, clean room real estate on equipment that's basically not needed to be in a clean area. So this is the chase here. No HEPA filters on the roof. Okay, and we have pumps and equipment that sit back here and support the equipment that we use to make these little devices. So now we're going into an area where we deposit material. So this is an old evaporator from Intel. It still works. We can do up to 18 wafers a time. Okay, it's pretty cool. It looks like something out of Doctor Who for your old folks on the line. Might remember who Doctor Who is, but this old electronic equipment still functions great, and we keep it running. We got two really good technicians from, they used to work at Intel and Philips and places like that, and now they're working for us here and helping us keep everything running. These spin rinse dryers you find everywhere in a clean room. They're basically to clean the wafers after certain steps in the process. Right here, some furnaces. These can go up to 1100 degrees Celsius. We use it to grow oxide, for example, and we can also deposit other materials using low pressure chemical vapor deposition. Okay, and then the stuff that goes inside are these quartz tubes. The quartz can handle up to 1400 degrees Celsius so they don't melt. And here's some wafers that have oxide grown on it. So silicon will rust just like iron will and create silicon dioxide. All right. So do we got any questions so far?
Actually, Matt, we do. And you kind of skipped it because you said you didn't need to put it on, but people are interested to know how much equipment you have to put on to actually go in there.
Well, for our clean room, we put on a hairnet, right? A face mask. Now we use the COVID masks. I don't need to use one because there's no one in the fab. But when you're in the fab, typically you'll wear all of this gear. So you got a mask, you got a hairnet, you have a smock, you got blue bunny shoes or blue booties, we call them. Okay, and then you wear nitrile gloves on your hands, and then a Tyvek smock. So that helps keep the particles down.
Very nice.
Okay, but since I'm the boss, I can break the rules. Don't tell my boss that, though. I would have gotten all gowned up and stuff, but I was running late, and I apologize for that. I thought this was at 2:30, so I'm getting old, you know. So
no worries. A couple more questions. So do you feel claustrophobic when you have all that stuff on?
I don't, but some people do. So when I worked at Philips Semiconductors, we would hire people, you know, out of high school and stuff to be operators back then. This was decades ago. And they would, some of them would quit after a week because they couldn't stand wearing all the stuff. So when you work in an Intel or a Sandia clean rooms, places like that, they also have a helmet that you wear. And then air is forced into the helmet from the outside. So the air coming in is clean. And then it goes through a Hepa filter, like a vacuum cleaner backpack thing that you wear. And that keeps the particles from your breath from getting into the clean room. So some people who wear all that gear do feel claustrophobic, but it's not a large percentage of the population. So that's a really good question. You probably want to try this out before you go into a career. But there's lots of jobs outside of the clean room that support the clean room as well. Any other questions?
Yeah, about how big is the clean room?
This one I think is 6,000 to 10,000 square feet, but you know they have one in New York. It's the world's biggest clean room. It's a company called Global Foundries. They make a lot of Apple products and other products. They're a foundry, so many companies use them. And their clean room is the size of 2 football pitches. That's football, soccer.
Soccer, right.
So, you know, it's 200 yards long and probably 50 yards wide, and that's how much area they have for their clean room. And it's about a $10 to $15 billion facility because the equipment's real expensive.
How you were just mentioning that there were a lot of other jobs that support the clean room. Could you talk about a couple of them?
Yeah, well, in the clean room, you can be a process engineer, a process technician, equipment tech, process technician, right? You can be in logistics, you can be a supervisor. Outside the clean room, you could work for companies that make the equipment, right? Those are called equipment engineers, and also service engineers. The people who come fix this equipment have to be engineers, usually because they're so complex. Now, there are a lot of technicians that work their way up in a company and they're able to do the same job as an engineer. So they get the title as well. Other things is the electrical guys, the HVAC guys, the guys who do the heating, ventilation, air conditioning. They also have to do other things outside of just that. They have to provide deionized water, different kinds of electricity, very clean air, nitrogen gases, and then all sorts of toxic gases have to be delivered into the clean room in a very safe manner. So there's lots of engineering jobs and facilities jobs to support that. So you got the equipment guys, and then you've got the chemical support people. You also have safety people, right? We have safety people at UNM that make sure we do everything safely. I'm responsible for the safety in our clean room because I'm the manager, and those sorts of things. So I can show you some of the fancy equipment we got if I can turn this camera around. Oh, and now this thing.
Oh, I have one more question while you're doing that. What happens if there's a problem and the clean room gets contaminated?
Oh, we had a BBR3 gas release about 5 or 10 years ago. And, you know, everybody evacuated, and then we let the ventilation run for a while. Folks came in with Scott air packs, which are like scuba gear that the firemen use, and secured the chemical leak and all of that. So yeah, sometimes you have to evacuate. We've only had to do that once, and we learned a lot from that. So knock on wood that we don't have to do it again in the future. But we've been very safe. No one's died or gotten severely injured in our clean room. Maybe a couple of chemical burns on their hand because they weren't following proper protective equipment protocols. So, but that's rare. That's very rare. So this is a really cool machine. This is called a sputter tool. Okay, so sputter puts thin layers of material onto the wafer, and we can do all sorts of metals and oxides and things like that. We have another old tool. This is an evaporator. This here is what we call a deep reactive ion etcher. So they make little holes in silicon. It's about a $1 million piece of equipment. So we just spent about $100,000 fixing it. And it's running really good. So we got one of our graduate students who's characterizing the tool, making sure it works like it's supposed to, and then we'll be releasing it to the companies that work with us here. And there's one of the older wafers, first runs. You can see there's some uniformity issues, but we'll go ahead and you know, we fixed a few things since then. This is a Perylene Coater. Perylene's used to coat things that go in the human body to make them biocompatible. So we can make things in here. Man, I keep losing you guys. I hope you can still hear me.
We can hear
there
you.
We go.
You just keep
Yeah, it's weird. I pushed the wrong. They got two buttons next to each other, and I got fat fingers. So. So let's see. We got about 6 minutes left, I think.
Yeah.
I'll just quickly.
Okay, so wait, I had one question about the machine that you were just showing and the wafers. What materials are used to make the wafers, and I guess that machine in particular?
The material is pure crystalline silicon. So it's got the same crystal structure as diamond, but it's silicon instead of carbon. So you can see it has facets when you etch it. Right, you can see that like a diamond, it has crystal planes. Hopefully you can see this kind of good.
Yeah, we can see it pretty good.
So that's silicon, and a lot of stuff's made on silicon. Here's another product from a company that used to do stuff in our clean room. The guy sold his company off. He made millions of dollars, so he did all his research in here. And then this is back of a solar panel. They used to make solar panels in our building. Advent Solar. This is polycrystalline silicon. So you can see multiple crystals. This thing that I just showed you, this guy, that's one crystal. And this is many crystals. You can see it breaks. So yeah, there's a lot of cool stuff in here.
They also asked if there were water fountains in there.
Nope, you got to leave the clean room and to have a drink.
So no drinks or food or anything like that allowed?
No smoking, no drinking, no fun. No, I'm kidding.
I will get thirsty a lot.
What else you got for me? I can tell you a little bit about UNM.
Yeah, that sounds good. We don't have no more questions right now, but
So I teach in the mechanical engineering department as well as manage the clean room. I also run a grant for the National Science Foundation on micro nanotechnologies. And so if there are any teachers online, we do professional development stuff, and we actually give you money to come to our professional development opportunities. And in terms of the mechanical engineering teaching, we do have a freshman course called Mechanical Engineering Design 1. It's also known as ME 160L, but you won't remember that. But that course is dual credit, dual enrollment. So if you're a junior or senior in college, you can take the class while you're still in high school and get credit for the Design 1 class. So I teach that. In fact, I'm going to teach that at 3:30 today. Yeah, you can take that course while you're still in high school. We got about 6 or 7 high school kids this semester taking it. So, you know, we would love to have more of you, you know, take the class while you're still in high school and see if you like mechanical engineering or not, you know, and if you're interested in that, you can continue on at UNM.
I do have someone that's interested, I think, in the teacher professional development. I'm just going to have them email me, and then I can pass you on that information, Matt, if that's okay. Did I lose everybody?
Me, and we do have, you know, our nanotech education special interest group we meet about every month, so we can add you to the spam list, and you can come to those meetings as well and meet all the folks from around the country that teach micro nanotech. It's a growing field. You know, there's like they're saying there's 100,000 jobs a year that can't be filled because, you know, people don't have the education for these different areas. So we're trying to fill that gap. And we focus on technician education because we really need techs badly in this country. We don't have enough technicians. And you could get a 2-year degree technician and make, you know, $50,000 a year, and in 10 years you'll be making over 100,000. So it's a good gig if you get into it.
Okay, well, we're our last couple of minutes to see if anyone has questions. I'm going to share my screen, which has our outro graphic and where you can find out more information for what's going on the rest of the day and next week. And also, if you give us a feedback form there at the bit.ly link, you'll be entered for a daily drawing. So while does anybody else have any more questions for Matt?
Yeah, can you tell me how many people showed up to this thing?
Yeah, we had 20. And I think I have a couple teachers on that might have been screen sharing. So I'm going to try to find that out. But right now we had for sure had a count of 20. And Matt, I'll pass along anybody that gets in contact with me about the teacher development program. I'll go ahead and forward them your way. And then you can.
Yeah, and also if they're interested in the freshman class, they can get a hold of someone in the mechanical engineering department, or I can forward their questions to them, and they'll get them situated to enroll in the class if they want to.
Yeah, that sounds great. Well, it doesn't look like there's any more questions, so I'm going to go ahead and tell everybody thank you for joining us. Thank you, Matt, for the presentation and the tour of the lab and the information. And again, thank you for joining Science Fiesta. We do have, let's see, at 3 o'clock, we have Exploring Credit with Fidelity Investments coming up. And then at 4 o'clock, Hyperbolic Geometry. If you guys are interested in any of that, please go to the website and you can sign up there. And again, thank you, Matt, very much. And all of you guys have a good afternoon.
Well, you guys have a great day.
Do you know the secret code?
Oh, secret code. Yes, let's do, Matt, pick a secret code word for these guys today about the presentation. What do you think?
Clean room.
There you go. Secret code word is clean room for today.
Thanks.
And I will type it in there. Yeah, sure. They're doing passports, and in the passports you have to put a secret code word, which is fun. So clean room, there we go.
All right.
All right, guys. Well, thank you so much. And thank you, Matt. And I'll be in touch soon about some stuff for my program.
All right. Yes, absolutely. Anything I can do to help. You guys have fun and study science.
All right. Thanks, guys.
Yeah.
Bye-bye.
No, I'm available. What, you had another question?
Yeah, it looks like there was one more question that popped on last minute. How many machines are in the clean room?
In ours, there's probably about 40 right now. But if you go to a typical, like a big fab, you can have hundreds of pieces of equipment, and some of them are, you know, could be as high as $150 million.
Wow.
So that's why they pay the engineers so much.
Right, they got to take care of that expensive equipment.
Yep. All right, you guys take care.
All right, goodbye.
Bye-bye.
Bye, Mitzi.
Bye. Bye.
They're so cute. All right, Matt.
Ciao.
We'll see you later. Thank you so much.